Since we've learned our sine, cosine, and tangent functions, now what we're going to do is we're going to work them backwards by using the inverse functions. What we learned basically the last few days we've been working with is we learned that, the sine of an angle is the length of the opposite side over the length of the adjacent side. And we had a triangle problem. We got kind of an angle. We had a specific angle here. We knew what the ratio was. We could have our calculator look that up. It gave us a decimal value, and we used it to solve for one of the unknowns being either the opposite or adjacent. Today we're going to look at what happens when the unknown is the angle. But we know the opposite and we know the adjacent. How do we do that? That's called using the inverse function. We use the inverse function, or on your calculator, you'll note the little sine -1, tan -1, cosine -1. That means the inverse function. We use the inverse function when the angle is what's unknown. And basically what we're doing is saying, okay, I know the ratio of the sides. So just very quickly, a very quick example here might be, here we are. Here's our angle A, and that's going to be our perspective. And let's say I know that this side is 10 and this side is 21. Okay? So just like normal, we say, okay, here's my perspective. This is the hypotenuse. This is the opposite. And this is the adjacent. I know the opposite and adjacent. Opposite and hypotenuse. And since I know opposite hypotenuse, that's going to be the sine function. So sine of my angle is 10 over 21. Opposite over adjacent. We've been doing that for a little while. The problem is, now the angle is unknown. Now I can turn this 10 over 21 into a decimal if I want. If my calculator turns on. Hold on here. There we go. 10 divided by 21 is about 0.4762. All right. So what I'm going to do is basically use my calculator now to look up what angle has that sine value. Because we've been using our calculator when we knew the angle to find the sine value, we're just working it backwards. It's the inverse function. What angle has that? So the way I do that is in my calculator, I put in sine inverse of that decimal, or if I don't want to convert it, I can actually put the ratio in there, and it's going to give me the angle. So this time we're going to do second function sine, in most cases or shift sine, depending on your calculator. And it should say sine inverse on the screen on the calculator. And you could either put in that decimal 0.4762 or the angle 10 over 21, ratio 10 over 21. And close that off, and you should be able to find the angle. Now, very important tip. I got some funky number like 0.4963, which doesn't sound like a very reasonable angle to me. And the reason that happened is because my calculator was in the wrong mode. Calculators have modes that go with angles. There are other ways of measuring angles other than degrees. The main other way is called radians. We always use degrees in geometry, so you have to make sure our calculator is in degree mode. If your calculator is in the wrong mode, you will be getting the wrong answers all the time. So be very, very careful of that. Be sure you check your mode as in degrees. So I'm going to try again, this time with my mode in degrees. So second function sine 10 over 21. And it gave me 24.43 degrees. Okay. Now, if I had done the decimal instead, if I had pre-done the decimal, sine inverse of 0.4762, it gave me 27.44 or 28.44 degrees. Sorry, should be an 8. Is that an 8? So it was off by 1/100 of a degree because I rounded a little bit here. I mean, going from here to here, we rounded just a teeny bit, and so makes a very slight difference, but usually it's only going to ask the nearest tenth of a degree or the nearest degree, so we're fine. So if you want to do it as a decimal or you want to do it as a ratio, it makes very little difference in your final result. All right, so this time I'm not even going to give you a triangle. I'm just going to tell you what the value is. You tell me what the angle is. The tangent of A is exactly 0.75. What's the angle? So what we're going to do is we're going to do the tangent inverse of 0.75, and that should give me the angle. So second function tangent, 0.75, and it gives me an angle of approximately 36.9 degrees. Sine of B, sine of some angle equals 0.87. Again, very straightforward. If the angle is what's unknown, we use the inverse function. Sine inverse of 0.87 equals B. So second function sine inverse, 0.87, and the angle is 60.5 degrees, the nearest tenth. Okay? Very, 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 very important. We use the inverse function when the angle is unknown. If the angle is known, if we know what the angle is, we use the regular function. Do not mix those up. The inverse function is only used when the angle is what's unknown. Here's one for you to try. All right, now that we have this inverse function, we can actually do what's called solving a right triangle. Solving means finding all the side lengths and all the angle measurements in a right triangle. We can find everything. Now, in order to do this, first we have to know we have a right triangle, which means we know one angle. And then I'm going to need either two side lengths or one side length and the measure of one acute angle in order to do this. So this is actually kind of an interesting process. Now we can actually find out everything about a right triangle if I know it's right, and one other piece of information basically is, well, two other pieces of information. So, sorry. So here's a triangle. I want to solve it. I want to solve the right triangle. Round answers to the nearest tenth. I need to find measure of angle A, measure of angle B, and side C. Now, in this particular case, look at what we know. What do we know? I know two sides already. And if I know two sides of a right triangle, how do I find the third side? Oh, when we know two sides, we find the third side using Pythagorean theorem. Pythagorean theorem. Pythagorean theorem. Okay. Pythagorean is how I remember how to spell it. So that's pretty easy. Here the unknown side is the hypotenuse of the triangle, so that's going to go by itself. So it's 2 squared plus 3 squared equals c squared. So that's 4 plus 9 equals c squared. So 13 equals c squared. So c is the square root of 13. Now for side lengths, if we're using Pythagorean theorem, we'll generally leave them in exact values. We don't need to approximate that. Square root of 13 is a great value. Okay? We don't need to approximate that and round to a tenth. If I'm solving a side length using trig functions, sine, cosine, or tangent, then everything will be approximated to the nearest tenth. Anything we solve using trig will be approximated to the nearest tenth. Anything solved using Pythagorean theorem or special triangles or something like that, then we'll use exact values. Great, I got that third side. Now I need to find my angles. I have to choose which angle to find. Because once I find one angle, the other angle will be easy because they have to add up to 180. So I can choose to find either angle A or angle B. I'm going to choose angle B and make this my perspective. If that's my perspective, identifying the sides, 2 is the opposite, 3 is the adjacent, and square root of 13 is the hypotenuse. Now, I'm going to be very careful not to use this measurement. This is the caution measurement right here. Okay, caution. Because what if I made a mistake in Pythagorean theorem, then all my other calculations would be off. Not because it's a hypotenuse, not because it's the biggest, but because it's not a given value. I really want to stick with my given values. So instead I'm going to choose angle B, and I'm going to use the opposite and adjacent sides. Now, since I know opposite adjacent, so ka, toa, opposite adjacent, no sign is opposite hypotenuse, cosine's adjacent. Opposite adjacent is tangent, so tangent is the function I'm going to use. So the tangent of the angle B is 2/3. So in order to find the angle, I'm going to have to use the inverse function because the angle is unknown. Tangent inverse of 2/3 equals the angle B. And I get out my handy-dandy calculator. Second function tangent, 2/3, gives me the angle is about 33.7 degrees to the nearest tenth. Which means now this third angle, because the angles of a triangle have to add up to 180, now I've taken away 90 for the right angle. The right angle was 90. So I have 90 degrees left to spend in this triangle. I spent 33.7 of those degrees here. That means my other angle has to be 56.3 degrees. I don't need to use trig again. I can just use triangle sum. Is that a little bit risky? Yeah, because 33.7 is a calculated value, not a given one. But that's generally the way we do it. If we find one angle, we find them both. It's kind of an all or nothing deal. And we've solved that triangle. I know all the sides and all the angles. Once again, solve the right triangle and round decimals to the nearest tenth if I need decimals. Here I've got sides of 20 and 21. Same situation. Third side is going to be Pythagorean theorem. So 20 squared plus 21 squared equals c squared. That's 400 plus 441 equals c squared. So it's 841 is c squared. So c is the square root of 841. Now, I don't know if any perfect square is going to 841. I'm just going to leave it that way for now. Now I have to pick an angle I'm going to work with, either D or E. I'm going to pick E. There's my perspective, which makes this a hypotenuse, this the opposite, and this the adjacent. The sides I know, once again, are the opposite adjacent, so that's a tangent function. The tangent of E is 20 over 21. So we do the tangent inverse of 20 over 21 to get the measure of E. Now it's calculator time. And I get 43.6 degrees. That means the other angle is 46.4 degrees, just a little bit bigger. Does that make sense? Yes, because 21 is opposite the bigger angle, 20 is opposite the smaller angle. So it makes sense. And we're all set. I've solved that triangle. It really is that quick. Very, very important point. Don't try to do this in your head. Write down your steps. Write down this equation, tangent E equals 20 over 21, before you write the tangent inverse equation. Or if it's sine or cosine inverse, doesn't matter, same way. Here I know one of the acute angles, which means finding the other acute angle is a breeze. I don't have to use an inverse function here to find angle G, because I already know two angles of my triangle. This has to be 65 degrees. Because the three angles have to add up to 180. Finding side G, however, is going to take some trig work, and this is going to be one of your assignments. But just to help you out a little bit, I'm going to find side H first. Now, when we're doing two sides like this, we generally don't use Pythagorean theorem. We'll use trig for both sides. And we'll generally not use angle G because what if I made a mistake here? I'm going to use angle H as my perspective because that's my given angle. So this is the opposite side. This is the adjacent side. This is the hypotenuse. And we start setting up our equations. In order to find H is the opposite side, and the known side is the hypotenuse. Opposite hypotenuse is sine. So the sine of angle H, which is 25 degrees, don't have to solve for that, I know it, equals the length of the opposite over the length of the hypotenuse. A little unfortunate that they chose H for a variable there when it's the opposite side. That's kind of awkward, but we can make it work. And I solved this by multiplying both sides by 13. 13 times sine 25 equals H, and that's a calculator problem, 5.5 approximately. Now you set up and solve an equation to solve for side G. That will be your final check of the day. We'll see you in class.